So it means the board lecture book should be different from that which you are teaching, right?
Yes, sure.
Okay.
Okay. Now, please pay attention, students. When you're speaking about with respect to your work energy parts, it's considered to be three different parts. Students, the work done by the body is due to the energy possessed by the body, students. But there is a correlation between all of them. Listen carefully, students. The work done by a body, okay, work done by a body is because of the energy possessed by the body. And the rate at which work is done, okay, this rate at which work is done is simply considered the power exerted by the body. That means there is an interlink between these physical quantities, students. If in case if I want to go with respect to work in the first case, students, what exactly work is defined as, students? Work is defined as, listen carefully, students, when force applied to a body produces displacement in the body in the direction of the force, work is said to be done. I repeat, work is defined when applied force produces a displacement of the body and the displacement takes place in the direction of the force applied, then work is said to be done, students. So since force and displacement both are vector quantities, work is still a scalar quantity, students. That's why we can consider work to be what? As a dot product of force and displacement. Students, you must have come across in vectors. Have you learned in vectors that work is equal to a dot product of F dot S, students?
Yes, sir.
Yes, sir.
Okay, so it's a dot product of force and displacement, students. Okay, applied force and displacement we consider if in case when you look into it, then there is a dot product in the two we consider. So work done we consider is a scalar or a dot product we consider. So this is the formula for work done. Now, when I remove the dot product, you have a component. It's therefore work is equal to, can be written in terms of F S cos theta, students. Now listen carefully. This means this means that if the displacement, listen carefully, students, if the displacement and the force, this is the first example I'm trying to put forward, or in the second case, students, there's an inclined plane and the block is placed over here. Listen carefully, students. If in case, in the first case, look at the displacement is horizontal, the applied force is inclined at an angle theta with the horizontal, students. Second case, where see the applied force. The applied force is horizontal, students, and the displacement is along the inclined. Now, when I put forward, students, is F and S, are they in same direction in both the cases? No. यहाँ पे force incline है, body horizontal जा रहा है. यहाँ पे body inclined plane पे move हो रहा है, लेकिन force horizontal जा रहा है. So when exactly work is said to be done? When applied force produces a displacement in the direction of force, students. The definition states that work is said to be done when the applied force produces a displacement and the displacement of the body takes place in the direction of the force. Then work is said to be done. So यहाँ पे क्या हो रहा है? Force और displacement एक direction में है नहीं. So what do you do? So you drop a perpendicular. If I drop a perpendicular, students, you tell me what is the component? What is the component of force we consider is? So the component
F cos theta
will be F cos theta. Agreed? You have F sin theta are the two components. This F sin theta is going to balance the weight of the body throughout the motion, students. जब भी body move कर रहा है, students, throughout the motion, your F sin theta will balance the weight of the body. But what about F cos theta? F cos theta is a component of force which actually is the cause. ये है तुम्हारा cause for the body to undergo displacement. तभी जाके students work over here is represented as F cos theta into S. Is this clear with all of you?
Yes, sir.
Yes, sir.
Likewise, if you look over here, यहाँ पे देखो, यहाँ पे ब्लॉक को जाना था इंक्लाइन प्लेन पे, लेकिन तुम पुश कर रहे हो हॉरिजॉन्टली, तो क्या यहाँ पे भी फोर्स और डिस्प्लेसमेंट एक ही डायरेक्शन में? नहीं, एक डायरेक्शन में नहीं है। अगर तुम्हें ब्लॉक को अलोंग द इंक्लाइन प्लेन मूव करना है, तो इसी के कंपोनेंट्स में ना, इसी के, तो एक कंपोनेंट अगर मैं अलोंग, ध्यान से सुनो, एक कंपोनेंट में अलोंग द इंक्लाइन प्लेन लेता हूँ, तो दूसरा आई कैन टेक इट इन दिस डायरेक्शन। आई गेटिंग इट? I can consider this direction.
Yes.
But now when I speak about it, what exactly the component I can consider? Students, if you look over here, I'm not going to component for the F, because see, this component is not balanced. Answer देखना students, ये F के दो components अगर मैं लेता हूँ students, तो ये देखो, ये component balance नहीं है. Nor even this particular one is in the direction of it. So rather than students trying to balance S, we consider, or breaking S, we try to break up S into two components. We'll try to decompose S. Students, S को हम यहाँ पे decompose करते हैं, ना कि F. Agreed? Now suppose if I say, if I happen to consider this as angle theta, I can consider, even this angle is also theta, I can consider. Agreed? If I consider these two are parallel angles, I can consider both of them are parallel angles. I can consider these two angles are congruent. Corresponding angles I'll consider. तो ये क्या हो जाएगा तुम्हारा? This I'll consider S cos theta. I'll consider in this case. Is that clear? Is it in the direction of force? Yes. We can consider. या तुम अगर F को अगर लेते हो, students F का हमारा दो components I can consider. यानी I can take it one in this direction we consider. Agreed? So if in case if I take this as theta, ये भी तो theta होगा students, vertically opposite angles. So can you tell me what is this component? So this is F cos theta. Is this F cos theta now in the direction of displacement? Yes. If F cos theta is in the direction of displacement, students, is work said to be done? Yes, work is said to be done. So in either case, students, हमारा force जो होगा वो हमेशा displacement के direction में ही चाहिए. In order to have the applied force should be in the direction of the displacement, you need to go for component of force, students. Therefore, we say work is simply a dot product of F dot S or simply Fs cos theta we consider. Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Now looking at theta, students, जैसे तुम theta को देखोगे तो यहाँ से तुम्हें पता चलेगा कि work done can be considered as positive, negative, and zero. Now see, looking at theta, one can come to conclusion, can work done be positive, negative, and zero? Yes, why not? Work done can be positive, work done can be negative, work done can be zero also. Now, if you happen to consider types of work done, students, types of work done. Work done can be positive, work done can be negative, work done can be zero. Students, मुझे बताओ, when exactly work done is said to be positive? तो तुम क्या बोलोगे? Sir, when applied force and displacement are the two vectors. अगर दोनों एक ही डायरेक्शन में है तो थीटा बन जाएगा 0. Cos of 0 क्या बन जाएगा? 1. So work is said to be positive. So what's my formula for work done? So work done will be maximum, and that will be simply F into S. When applied force and displacement, students, are in the same direction, theta is 0, cos of 0 will be 1, work done is said to be maximum. For example, a block is placed over here and you're trying to push the block horizontally. Students, तुम force apply कर रहे हो horizontally. Body का displacement भी उसी direction में है. दोनों के बीच में angle क्या form हो रहा है? 0. Work done is said to be maximum. But when exactly work done is said to be negative? Yani for work done is said to be maximum, which theta should be equal to 0. Can I say? The value of theta should also be less than 90 degree or greater than or equal to 0. क्या ये सही होगा students?
Yes, sir.
To be
Yes, sir.
positive, now theta should be less than 90 or equal to 0. If I take equal to 0, the answer, if I take it at equal to 0, what about the work done? Has to be maximum. But if I take any other value less than 90, students, what about the work done? Will be positive. Students, to do problems on the work done, a student should know about the corresponding values of work cos theta. Students, Let me put forward those angles, students, over here. Suppose if in case if I happen to go for theta, okay, and corresponding values of cos theta over here, students, 0 degree, 30 degree, 45, 60, 90, 180, 150, 135, 120. Since what is cos of 0 will be plus 1.
1
1
Cos of 30 will be how much? Cos of 30 will be
root 3 by 2.
root 3 by 2.
cos of 45 will be
1 by root 2.
yes. Cos of 60 will be
1 by 2.
by 2.
Cos of 90 will be
0.
180 will be
Negative 1.
ये क्या होगा minus root 3 by 2 135 and these are all supplement students. ये सारे आंसर्स नेगेटिव में होंगे, जो भी सप्लीमेंट होंगे सारे नेगेटिव होंगे। यानी अगर मैं पूछूं 180 सर 180 से सप्लीमेंट ऑफ 0 तो ये +1 होगा तो -1 होगा। 150 सप्लीमेंट ऑफ 30 minus root 3 by 2 135 supplement of 45 -1 by root 2 120 supplement of 60 -half. And students, from here you come to conclusion, agar value of theta is less than 90 or equal to 0, what is my work done? My work done will be positive. Lekin work done is said to be maximum for what angle? Theta 0. Kya ye clear hua, students?
Yes, sir.
Yes, sir.
Now for work done to be negative, students, what exactly? The value of theta should be students greater than 90 we consider, or less than or equal to pi circular. Now for example, if I say, listen carefully students, displacement is acting in this direction, let us say. The force is acting in this direction, students. Let us say the angle between them be theta. Is this theta greater than 90 and less than 180, students?
Yes, sir.
Of course, it's greater than 90 and less than 180, students. So it's an obtuse angle. अब मैं कैसे prove करूं कि work done is said to be negative? Students, work is said to be negative when the applied force and the displacement does not take place in the direction of the applied force. तो यहाँ पे अगर मुझे बताना हो तो मैं कैसा करूंगा स्टूडेंट्स? लिसन केयरफुली। व्हाट आई डू इट इज, डांस इज नो स्टूडेंट्स, मैं ये f को रिजॉल्व करता हूँ स्टूडेंट्स, प्लीज पे अटेंशन, विल गो फॉर सम वेक्टर्स। मैं f को रिजॉल्व करता हूँ स्टूडेंट्स। तो मैंने क्या किया, इसी को अगर मैंने परपेंडिकुलर ड्रॉप कर दिया, ये 90 मैंने ले लिया, तो व्हाट इज दिस एंगल स्टूडेंट्स? कैन आई से दिस बिकम्स थीटा माइनस पाई बाय 2। क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
Yes, sir.
I happen to decompose this f into two components. So can I say one is this, the other one will be this, two vectors mutually perpendicular to each other, है ना?
Yes, sir.
Resolution of vectors का मतलब क्या करो, तुम वेक्टर को डिकम्पोज करते हो into two vectors which are mutually perpendicular to each other. These are called as orthogonal vectors. तो एक क्या होगा, तुम लोग सर एक होगा f cos theta minus pi by 2। सर ये फोर्स तो ये जो बॉडी है उसका वेट के साथ में हमेशा एक्ट होता रहेगा, mg नीचे की तरफ जाएगा, क्योंकि लेट मी टेक द एंटायर मास ऑफ द बॉडी, एंटायर मास ऑफ अ बॉडी टू बी अ पॉइंट मास। तो इनसे सोचो कि एक ऑब्जेक्ट है जिसका डिस्प्लेसमेंट इस तरफ है, फोर्स इस तरफ जा रहा है, आई गेटिंग इट, फोर्स इज इंक्लाइंड एट एन एंगल थीटा, द एंटायर वेट ऑफ द बॉडी इज डायरेक्टली वर्टिकल डाउनवर्ड्स। व्हाट अबाउट दिस फोर्स? तो ये क्या करोगे सर? दिस इज f sin थीटा माइनस पाई बाय 2। क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
एक cos
Yes,
और एक
sir.
sin। Can you tell me students, can you tell me what's the formula of sine of, what is the formula of sine of a minus b, students? Can you tell me?
Sin A cos B minus cos A sin B.
Very good. Minus cos a
Sin B.
ना सी, अगर मैं ये सब्स्टिट्यूट करूं, देखो ध्यान से सुनना, ये तुम्हारा थीटा है और ये पाई है, तो स्टूडेंट पाई बाय 2 है, सॉरी। So can I say sin theta? What is cos of 90?
0.
0. Minus cos of theta. What is sin of 90?
1.
1.
So can I say my answer will be minus
cos A.
आया ये? अभी ध्यान से सुनना स्टूडेंट्स, अभी ध्यान से सुनना। तुम्हारा ब्लॉक ये था स्टूडेंट्स, तुम्हारा बॉडी सरफेस पे ये था, डिस्प्लेसमेंट इस तरफ जा रहा है स्टूडेंट्स। लुक एट द कंपोनेंट ऑफ फोर्स व्हिच इज एक्टिंग। हाउ इज द फॉर्मूला फॉर वर्क डन? I'll consider in this case. What's the formula for work done I can consider in that case? So can I say my formula for work done in that case will be equal to what? force and displacement, are they in the same direction, opposite direction we consider? Sorry, this will consider in terms of what? F sin theta we consider. So cos of 180 we consider, cos of A minus cos of B we consider. So sine of 180 will be, sorry, sine of 90 will be 1. And this is cos of theta, so it's minus cos theta. So can I say, this is called as which force? Students, this is the force of friction. Work is done. Students, work is done in such a way that the displacement and the component of force, are they in the same direction or they are in opposite direction? They're simply in what direction? Opposite directions. तो यहाँ पे तुम्हारा क्या होगा? Sir, work done will be equal to, simply I can consider as minus F cos theta into S I can consider. ये जो नेगेटिव है क्या बताता है? It's a force of friction we consider. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
So
So we
work
can
done,
prove it in a more simpler way.
yeah, by simply taking the angle theta.
No, sir, by extending F to a opposite side, so it would be negative F along that
Yeah.
direction.
Yeah,
And the
अगर इसका vector का change करो direction. That's what you're trying to say.
सर वो ऐसे इंक्लाइंड है ना, तो फिर ऐसे डिक्लाइन नीचे वहां से नीचे ड्रॉ करेंगे तो
Okay, fine.
हाँ सर, वो नेगेटिव एफ हो गया. सो द थीटा वुड बी लाइक 180 माइनस थीटा. सो सिंपली एफ कॉस 180 माइनस थीटा.
Okay, that also can be done. Absolutely correct. Doesn't matter. Because see, whenever you try to go for it, students, तुम्हारा ये जो displacement होगा, it should be in the direction of the applied force. तो अगर तुम करोगे तो F cos theta into S हो जाएगा. तो ये तुम्हारा आंसर नेगेटिव में ही आएगा हमेशा. क्या ये क्लियर हुआ students? Is this clear to all of you all?
Yes, sir.
Yes,
Now,
sir.
work done can be positive, work done can be negative, students. What about work done? When exactly work done is said to be zero, students? When exactly work done is said to be zero? तो तुम क्या बोलोगे?
Either no force is applied or along perpendicular direction force is applied.
Absolutely.
But no displacement.
Yes. So see, work done is said to be zero when exactly? Because first case we consider is what? When force is applied, students. So his work is said to be done when you are applying force on the body, but the displacement is zero. Work done is said to be zero. When no displacement takes place. Agreed? When no displacement takes place in that case, okay? Suppose there is a wall, okay? A huge rigid wall. And suppose if I tell you to push the wall, you're pushing the wall. Is the wall set into motion? No. जब ये displacement zero हो जाएगा, तो what about the work done? This also zero. No work is said to be set zero. In this case, second case, what exactly? So when force is applied on a body, and the displacement of the body and the force are mutually perpendicular to each other, students, then in that case, work done is said to be zero. Why? Because work is given by Fs cos 90. Theta over here will be 90 when force and displacement are mutually perpendicular, students. So what is cos of 90 will be equal to? Cos of 90 will be zero. So work done is said to be zero. So agar suppose ये block है and the displacement is in the horizontal direction, students, but the force of gravity of the body is acting vertical downwards, students, what is the work done in that case? Zero. If force of gravity is acting downward, what is the normal reaction force? Acting upwards. तो यहाँ पे students दोनों केस में ध्यान से सुनना, work done with respect to gravitational force and normal reaction force, in both the cases your answer will be zero. Why? What's the reason? So तुम्हें ये बोलना सर displacement horizontal है, normal reaction and displacement are mutually perpendicular, gravitational force and displacement are also mutually perpendicular, theta is 90, work done is said to be zero. Students, is this clear? Conditions for zero work done?
Yes, sir.
Yes,
When
sir.
force and displacement are mutually perpendicular. Now suppose in case if I give an example, students, I have a string, and to this particular string, students, I have connected a bob. Okay. Now suppose if I say a bob is undergoing an oscillatory motion, we consider. My question to the students, what is the work done by the force of tension in the string? Work done by the force.
It would be zero.
Why zero?
So the body is like moving in a similar motion to that of circular motion, and tension is like centripetal force acting at the center.
The theta is 90 as it's tangential.
Friends, the displacement is tangential. Every time when you consider the displacement is tangential, look at the displacement. And so look at the force of tension. What is the angle from between them? 90 degree. What is cos of 90? So cos of 90 will be equal to 0. Work done is said to be 0. क्या ये clear हुआ, students?
Yes, sir.
That is what you must have come across, students. Suppose if I make a person to walk on a frictionless surface, students, or an object is made to move on a frictionless surface, the surface is frictionless. Students, what is the work done by the gravitational force? Your answer will be 0. Why? Because Fn is mutually perpendicular. Likewise, you must have heard about a coolie. A coolie is carrying a load at his head, and the coolie is standing at one place. Has he performed any work in this case? No, because there is no displacement of the load. No work is said to be done in that case. But now suppose if the coolie walks in the forward direction, students, if he's walking in the forward direction, is there any work done by the gravitational force? No. How is the gravitational force, students? Downwards. Where is the displacement? Horizontal. What is the angle formed between them? 90 degree. Work done is said to be 0. स्टूडेंट्स यही ध्यान में रखना, जब भी ये वाला प्रॉब्लम या ये वाला कंसेप्ट पूछते हैं, वर्क डन बाय अ मैन हैविंग अ लोड ऑन टू हिज हेड एंड moving horizontally, तो read the question very carefully. Are they speaking with respect to the gravitational force? Are they speaking with respect to the weight of the man? Are they speaking with respect to the normal reaction force? अगर उन्होंने gravitational force word use किया है, pull of the earth use किया है, weight of the man along with the load use किया है, या normal reaction force use किया है, then in all the 4 cases work done is said to be 0. लेकिन work done by the man along the horizontal, of course, is walking in the forward direction. The force of friction is in the opposite direction. He is performing work. I get it. Against the force of friction. Against the force of friction, we consider. So one can consider in that manner, yes, work is said to be done against the force of friction, but with respect to gravitational force, it is 0. क्या ये clear हुआ, students?
Yes, sir. Yes, sir.
Likewise.
Yes, sir.
Likewise, suppose if I say natural planets we consider, okay, or satellites revolving around a particular object. For example, Earth revolving around the sun, Moon revolving around the Earth, or an electron revolving around the nucleus of an atom of an element, students. What is the work done by the force for electron to revolve around the nucleus? So is the work done positive, is the work done negative, or the work done is 0?
0.
Why?
0.
Why 0?
Displacement
Forming
is
a 90
tangential.
degree.
Who's forming it? Which angle?
Tangential rotation.
हाँ, tangential, लेकिन कौन सा force जो इलेक्ट्रॉन को रिवॉल्व करा रहा है उसमें?
Electrostatic force.
So,
Very
force
good.
of attraction.
Force of attraction. यानी ये electrostatic force है, nuclear force नहीं, students. Electron is made to revolve around the nucleus of an atom of an element by electrostatic force of attraction called as Coulomb's force. Students, so Coulomb's force is directed inwards. Displacement is always horizontal. So your force of electrostatic and displacement are mutually perpendicular. तो ध्यान से सुना, students. Work done by the electrostatic force is said to be 0. When you're writing the statement, also write down very clearly work किसके हिसाब से. Now suppose if I say, what is the work done by electron for one complete revolution?
0.
0. Why?
The displacement is 0.
Displacement of the electron is 0. Likewise, if I say Earth or a moon revolving around the Earth, it performs uniform circular motion. Which force is required for the moon to perform UCM, students?
Gravitational force from Earth.
Absolutely correct. And gravitational force, if I consider for a moon, students, for a moon, students, how is the gravitational force directed inwards? This is the gravitational force. This is the center of the circular path.
Centripetal force.
Yes, the force centripetal we consider, or वो है gravitational force. And displacement is horizontal. What are they? Mutually perpendicular. So the work done by the gravitational force of the Earth is said to be 0, students. For one complete displacement, so one complete revolution by the moon, the work done is said to be 0 because there is no displacement. So students, 0 work के लिए very clearly have to be specific. Theta क्या होना चाहिए? 90. And theta, students, in all the cases is the angle between force and displacement. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
Now when you go with respect to the unit, students, all of you are aware about it. If I happen to go for the SI unit, students, what exactly SI unit we consider? So the SI unit of work we consider always include that SI unit. Agreed. The MK since just all of you are aware about it, students, I can write on either joule or Newton meter, and it's erg or dyne centimeter, students, we consider. Students, 1 joule is equal to how many erg? What's the relation? 1 joule is equal to how many erg?
10 to the power 7 ergs.
10 to the power 7. Or 1 erg is equal to 10 to the power of minus 7 joule. Do take care of this also. Can I erase this, students? Can I erase it, students?
Yes, sir.
Yes, sir.
Correct. Students, listen carefully. A block is given to you, and a block is placed on a surface, students. Okay. Applied force I'll consider will be equal to 20 Newton, students. Let us say the displacement is 10 meter. This is the force applied in the first case, students. This is the force applied in the second case at an angle of 60 degrees, students. Okay. The weight of the block, students, it's 1 kilogram force. Agreed? 1 kilogram force, students. And if I say there is a force of friction acting on the block, which is equal to 2 Newton. Students, my question to you all is, listen carefully, students, okay? My question to you all is, what is the work done in each case? Okay, work done, students, due to applied force. Are you getting it? Work done due to inclined force. Work done due to frictional force. Work done due to, or this fourth one I'm writing out, simply useful work done. Useful work done, students. Fourth one is useful work done. Work done due to applied force, work done due to inclined force, work done due to force of friction, and work done due to normal reaction force. So I want 1, 2, 3. This is the fourth one. And the fifth one is a separate question. I wanted to find out the useful work done. Get me the answers in all the cases. Students, is the question clear?
So could you explain the diagram once again?
Once again, the diagram putting it, a block is placed on a surface, students. Okay, the displacement in all the cases, students, the displacement in all the cases, I'm taking it as equal to 10 meter. Okay, in the first case, the applied force is taking place in the direction of the displacement. That's our F1 we consider. Okay, 20 newtons. F2 is at 20 Newton at an angle of 60 degrees with the horizontal. Your force of friction is 2 newtons and the weight of the body is 1 kilogram force, students. My question to you is find out the work done in the first 4 cases due to applied force, due to inclined force, force of friction, normal reaction force. And the last one, the useful work done. Get me all these answers, students. Farhan Patel. Farhan Patel. Farhan, don't be in a rush. Okay, think properly and get me the answer. Neha.
Sir, F1 and F2 both are applied forces.
In the first case, the force applied is 20 Newton. Second case is also 20 Newton, but it's at an angle of 60 degrees.
Okay, sir.
Okay, Izar. Absolutely correct, Izar. बाकी दो के आंसर्स इज़ार, बाकी तीन के आंसर्स कहाँ पे? Izar, you're from purple, isn't it? Neha, you also from purple?
Yes, sir.
Okay, I'm happy that the students of mine are doing it. Yo, come on. You, where are your other friends? Your group? There comes Ages. Very good. Ages have got it. Since I've got the answers from teachers, Arush. Okay. Now let us get the answer. Students, let us get the answer. Okay. Now please try to just let us solve it. With answers from the students. If I ask you what is the work done due to applied force, students, when I speak about applied force, that means this is the force applied. So work done, students, is equal to F1 into S into cos of 0. Because students, F1 and S are both parallel to each other, students, and both of them are at an angle of 0 degree. So your work done will be equal to applied force is 20, displacement is 10, and cos of 0 will be 1. So the answer will be 200. That's the answer for the first. Okay, W1. Work done due to incline we consider is your work done F2 will be equal to what, students? Will be equal to what? Will be equal to force in second case displacement into cos theta, and that is 60 degrees, students. What is the force? Is 20 Newton. Displacement is 10 meter. Cos of 60 will be half. That means 100 joules. Is that clear, students? Work in second case. Work done with respect to force of friction. So what exactly W3 will be equal to, students? How exactly your force of friction and displacement, students, are they in same direction or opposite direction? No, students?
Opposite direction.
Opposite direction.
So what exactly consider will be H2 into what exactly consider will be 10, and that will be equal to minus 20. We consider that many joule we consider. Negative sign shares that work is done against the force of friction. Work is done against the force of friction, students. Normal reaction force. Students, what is the normal reaction force? What is the normal reaction force over here? Then your answer is normal reaction force is equal to the weight of the body, and weight of the block is equal to M into G. How much is the weight we consider as 1 kilogram force? Since 1 kilogram force corresponds to how many newtons?
10 newtons.
10 newtons is actually 9.8 newtons. अगर दिया हो 10 तो use करना 10, नहीं तो you can go for 9.8, doesn't matter in that case. Agreed?
Yes,
Students,
sir.
is it clear with all of you all? तो यहाँ पे देखो students, ये क्या मानो students, 1 kilogram force, these are called as gravitational units. What these are? Students, gravitational units are two, one in NKS and the other one is in CGS. Students, kilogram force is the NKS unit and gram force is in the CGS unit. When somebody asks you, students, what is 1 kilogram force? 1 kilogram force is that force exerted on a body, okay, when made to fall freely under the gravitational force of the earth. It comes down with an acceleration of 9.8 meter per second square. That's why it's 9.8 Newton. 1 gram force corresponds to how many dynes? Can you tell me that? 1 kilogram force is 9.8 Newton. Suppose अगर मैंने 1 gram force दिया होता तो क्या करते? What would I have told? If I would have gone for 1 gram force, क्या बोलते?
Sir, 98
So
raised to 6.
9.8 into 10 to the power 5 dyne.
No idea. It's not. Just convert kilograms to grams now. Hello. 1 kilogram force we consider is equal to what? 9.8. 1 kilogram into 9.8 meter per second square. So it's simply it will be 980 dynes. क्या ये clear हुआ students?
Yes, sir.
Students, अब वापस बोल रहा हूँ students, 1 kilogram force का मतलब क्या? कोई भी object when it falls freely under the influence of gravitational force of the earth, students, it comes down with uniform acceleration of what? 9.8 meter per second square. अगर यही मैंने लिया है 1 gram, it's going to come down with what? So this is 1 meter. 1 meter is equal to how many centimeter? 100 centimeters. So 980 centimeter per second square. Multiply करो, क्या आंसर आया? 980 times. Just मैंने क्या किया? मीटर पर सेकंड को कन्वर्ट कर दिया सेंटीमीटर पर सेकंड स्क्वायर. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
This is a definition of 1 kilogram force, students. ये है definition of 1 kilogram force. ये है definition of 1 gram force. 1 kilogram force is that force exerted by the earth on the body of mass 1 kilogram, and when the body is set to fall freely, it comes down with an acceleration of 9.8 meter per second square. Whereas a 1 gram force when made to release vertically downwards, it moves on with an acceleration of how much? 980 centimeter per second square. Is this clear, students?
Yes, sir.
Yes,
So now
sir.
when I say about weight of the block, can I say weight of the block is 9.8 Newton? Now, how is the work done in this case? Work done due to normal reaction force. Because normal reaction force, can I say it's in the direction opposite? The normal reaction force and the weight are equal in magnitude opposite direction. But how is the displacement of the body? Is the displacement of the body is perpendicular to it? Yes. Since normal reaction force and displacement are mutually perpendicular, students, work done is said to be
0.
0. Cos of 90 will be 0. क्या ये clear हुआ? Is this clear, students?
Yes, sir.
Sir,
What is
can you
this?
explain it again?
Work done by normal reaction force, students. Okay, what is the normal reaction force acting onto you?
So can you please wait for a second?
Oh, very sorry. What is the normal reaction force acting onto you? Can I say that is equal to your own weight?
Yes, sir.
So if I say the weight is 9.8 newtons, what's the normal reaction force also is acting as how much?
Same as my weight.
Yes, but is the body moving horizontally?
Yes, sir.
So what is the angle formed between the normal reaction force and the displacement?
90 degree.
Of course. So in that case, the work done is said to be what? 0.
Hmm.
Okay.
Okay, sir.
Now see, when I speak about the fifth one, useful work done. Useful work done यानी तुम किसको consider करके करोगे मालूम है students? Students, useful work done हम यहाँ पे करेंगे horizontal forces को लेते हुए. I'm not concerned with the incline part of it, students. Incline के through भी तुम कर सकते हो. मुझे बताओ what is the useful work done? अगर मैं बोलूँ ध्यान से सुनो students. What is the work done due to applied force? How much is this?
20 joules.
200 joules. Agreed? Horizontal. What is the work done due to force of friction?
minus 20 joules.
What is the useful work done in this case?
180.
180 joules.
180 joules.
Now suppose if I want to speak about useful work done, the answer is students. Block was placed on the horizontal surface. The answer is students. Applied force जा रहा था मेरा 20 Newton. Force of friction opposite direction में कितना था? 2 newtons. Students, what exactly the net force acting on the body? So can I say applied force minus the force of friction is that 18 Newton, students?
Yes.
Yes, sir.
Now that 18 Newton का force किस direction में होगा? Will it in the direction of the greater magnitude or smaller magnitude?
Greater.
Sir, greater magnitude.
Magnitude.
So, and the displacement of the body will be in the same direction. So what exactly a work done will be equal to, sir, it's F net into displacement and cos of 0. F net is how much? 18. Displacement कितना है? Sir, it's 10. So what's my answer? 180 joules. क्या ये clear हुआ?
Yes, sir.
For the useful work done.
Yes, that's a useful work done, eliminating the force of friction.
Sir,
Agreed?
the second force is also acting. So
No, coming.
component of that.
No, wait a minute. This I found out with respect to horizontal. Please, they will not give you two forces in one. Hello. मैंने इसी में अभी सपोज मुझे यूजफुल वर्क डन इंक्लाइन के हिसाब से निकालना है तो कंपोनेंट लेना जरूरी है आया ना
okay.
Yes, sir.
अभी उसके बारे में बात करूंगा पहले ये क्लियर हुआ मुझे ये बताओ यूजफुल वर्क डन विद रिस्पेक्ट टू हॉरिजॉन्टल फोर्स इज दिस क्लियर
Yes, sir.
Yes,
दूसरी बात अगर मैं बोलूं व्हाट इज द वर्क डन ड्यू टू हॉरिजॉन्टल फोर्स एंड वर्क डन ड्यू टू इंक्लाइन लुक ओवर हियर स्टूडेंट्स व्हाट इज द वर्क डन ड्यू टू हॉरिजॉन्टल हाउ मच इज द वर्क डन 200 इंक्लाइन के ऊपर कितना जा रहा है
100 joules.
यानी कहां पे तुमने एनर्जी ज्यादा कंज्यूम किया है व्हेन पुशिंग इट हॉरिजॉन्टली और व्हेन अप्लाइंग फोर्स इंक्लाइंड
Horizontally.
Horizontally.
यानी स्टूडेंट्स फोर्स दोनों केस में सेम था स्टूडेंट्स लेकिन where do you tend to lose more energy where do you tend to lose more energy by pushing it horizontally or by pulling it along an incline
Pushing it horizontal.
Horizontal.
more energy is consumed while pushing it horizontal. That is why students for luggage baggages you have a handle placed at one corner at a certain angle and the body is going to go horizontal. Yeah, ये clear हुआ for the time being. Now we go for inclined. Is this much clear, students?
Yes, sir.
Yes, sir.
Now suppose अगर मैं suppose ये वाला force को भी completely eliminate कर देता हूँ students ध्यान से देखना okay और सिर्फ force of friction रखता हूँ means now can I erase this part students everything
Yes, sir.
Since in one question itself only all your types have come into account. This is the force of friction. Okay. Now, this is what I'll try to do. If I want to go with respect to an inclined flow, तो मैं क्या करूँगा? Can I say I have to resolve these forces? Sir, ये F अगर act हो रहा है, तो can I resolve this into two components?
Yes, sir.
तो ये क्या हो जाएगा?
F2 cos theta
Cos theta,
and
F of
F
sine.
F2 sin theta.
agreed.
Yes, sir.
Now suppose if I say the body is moving horizontally, students. So should I go for the horizontal forces? Yes. Which are the horizontal forces I consider to be F cos theta? For the body, dances in students, for the body to move. Can I say my F cos 60 should be greater than the force of static friction?
Yes, sir.
Yes,
Force
sir.
of friction consider. I getting it? So the difference in the two forces will be the net force acting on the body.
Yes, sir.
And that net force, that means the difference between the two is that net force. This net force acting on the body, producing a displacement of how much? 10 meter will be the work done in this case. Kya ye clear hua, students? What is the net force acting on the body? It's F cos theta minus F. Abhi tum batao, force of friction kaise nikaloge? Force of friction, yahan pe diya hua hai 2 Newton. Are you getting it? That's what you
Yes,
have to
sir.
see.
Yes, sir.
That's your
Sir?
answer. Yes.
सर एफ साइन थीटा पहले ही नेग्लिजिबल हो जाएगा ना फिर?
ये तो हमेशा बैलेंस होगा. हेलो, ये ऊपर
हाँ
और
अरे
नीचे
सर
की-
परपेंडिकुलर
हाँ,
टू दी मोशन.
yes, displacement के हिसाब से तो वो तो I will not consider them. I will not consider them at all throughout the motion, because उसके हिसाब से तो वर्क हो ही नहीं रहा है ना. अगर मैं नॉर्मल रिएक्शन फोर्स ऊपर ले रहा हूँ और साथ में अगर F sin 60 भी ऊपर ले रहा हूँ, डिस्प्लेसमेंट तो मेरा हॉरिजॉन्टल जा रहा है. व्हाट इज द वर्क डन बाय द समेशन ऑफ फोर्सेस एक्टिंग अलोंग प्लस J कैप? 0 है ना, क्योंकि फोर्स एंड डिस्प्लेसमेंट आर परपेंडिकुलर. अगर मैं नीचे की तरफ लेता हूँ तो ये मेरा mg और इसके साथ में दिस इज आल्सो 0. नो वर्क इज टू बी डन. मैंने एक्सेलरेशन के बारे में बात नहीं की स्टूडेंट्स. आई एम नॉट स्पीकिंग अबाउट लॉस ऑफ मोशन. हेलो, आई एम नॉट डूइंग लॉस ऑफ मोशन विद यू ऑल. आई एम डूइंग वर्क पावर एनर्जी. आई एम डूइंग वर्क पावर. अगर मैंने कहां पे पूछा स्टूडेंट्स व्हाट इज द एक्सेलरेशन पोजेस्ड बाय द ब्लॉक, तो तुम बोल सकते हो स्टूडेंट्स अप्लाइड फोर्स माइनस द फोर्स ऑफ फ्रिक्शन causes the block to move with an acceleration है. अगर मैंने फोर्स ऑफ फ्रिक्शन नहीं दिया है तो फोर्स ऑफ फ्रिक्शन ये ऊपर और नीचे जो फोर्सेस है इसके साथ बैलेंस करके यू कैन ट्राई टू गेट इट. Agreed, students?
Yes, sir.
Yes, sir.
So students, the bottom line is work is said to be done when applied force. When applied force produces displacement in the direction of the force applied. Now students, listen carefully. अगर suppose मैंने पूछा plot a graph, okay? For work done, if in case in the first case your force is constant, okay? Second case, force is variable. So now suppose if I happen to plot a graph, the answer is in students, where force is constant. This is the displacement I'll consider. Can I say, is this a constant force, students? Students?
Yes, sir.
Yes, sir.
क्या ये constant force है या variable force है?
Variable.
What about this?
Variable.
Variable.
Variable, है ना? non-uniform. Students, अगर ये force or displacement, if I happen to consider in all the cases we consider, तो ये constant force है. These two are examples of variable forces I can consider. लेकिन यहाँ पे क्या हो रहा है? अगर force constant, so can you find out the work done in this case? बताओ. How do you find out the work done in this case? तो क्या करोगे तुम?
F cos theta.
Yes. So can I say it will be the area under the graph? Since work is simply is equal to what? Force into displacement. So how exactly? Force is constant, students. So what exactly? I'll simply go for area under the graph, students. And what is the area under the graph? The area under the graph. Area under the graph will simply speaks about the work done, and that is force into displacement. How do we come to the conclusion with area under graph? Students, work is always measured in joule or Newton meter. Now, देखो force Newton में है, displacement meter में है, so multiplication of these two, length into breadth, and that's area of rectangle I can consider. क्या ये clear हुआ, students?
Yes,
Yes, sir.
Yes, sir.
Now suppose यहाँ पे अगर non-uniform graph है, students, non-uniform graph है, तो यहाँ पे तुम क्या करोगे? यहाँ पे work done कैसे करोगे? Sir, ये देखो ना, ये है, students, ये uniform in the sense यानी the body is covering equal increase in force with equal increase in displacement. लेकिन फिर भी वेरिएबल फोर्स है. यहाँ पे अगर तुम्हें वर्क डन करना चाहिए ना स्टूडेंट्स, ध्यान से सुनना, आई कैन सिंपली गो फॉर एरिया अंडर द ग्राफ. देखो, लेकिन यहाँ पे तुम्हारा एरिया ऑफ ज्योमेट्रिकल शेप क्या आ रहा है?
Area of trapezium.
अगर if I start my work done from this end to this end, so what exactly I consider? Since can I say I will not go for this part of the graph? I'll consider only this part of the graph because I started over here and out. Can I say this becomes area of triangle only, students? Half into base into height. क्या ये clear हुआ, students?
Yes, sir.
Yes, sir.
लेकिन जब ये वेरिएबल है, पूरा ही नॉन यूनिफॉर्म ग्राफ है, तो इसके लिए तुम क्या करोगे?
Definite integration.
इंटीग्रेशन. यानी तुम which part of the graph you consider? सर, ये जो ग्राफ के अंदर जो जिसका स्लोप तुम्हें 0 दिखता है, एक कांस्टेंट फोर्स दिखाई देता है, स्टूडेंट्स, वो पार्ट ऑफ द ग्राफ तुम लेते हो. देखो ना, वो पार्ट ऑफ द ग्राफ लेके और वहां से एक स्ट्रिप लेते हो. A small strip you consider, shade it. Can I say this becomes my displacement ds? Students, for small displacement, what is the work done? Students, for such a small displacement, what is the work done? So it's very small. What about the applied force? Did I select? Students, did I select in the graph the straight part of the graph? हाँ सर, आपने straight line वाला पार्ट. यानी फोर्स को मैंने कांस्टेंट लिया, स्टूडेंट, तब जाके F डाल रहा हूं मैं. ध्यान से सुनो, जब भी तुम्हारा वेरिएबल ग्राफ होगा तो वहां पे मैंने F को क्यों लिया है? क्योंकि ये एक स्ट्रेट पार्ट ऑफ द ग्राफ लिया है. What about the displacement, students? The displacement I'll consider will be equal to what? dx. It's raining heavily in Kharghar, or students? Is it?
No, sir.
No, sir.
No. Yeah.
It's raining.
Yeah, it's raining heavily in Kharghar, or what?
No, sir, not heavy
No,
right now,
sir.
but I think it might.
So it's only drizzling.
It's just drizzling. Okay, fine. Okay. प्रियम, अभी तो लेक्चर चालू है, अभी लेक्चर कहाँ खत्म हुआ है, तब तक तो तेरा सही हो जाएगा. ओके स्टूडेंट्स, ध्यान से सुना. इनका ध्यान ज्यादा करके लेक्चर्स को रिकॉर्डेड भेजने में है. Okay, ध्यान से सुना. Work done is equal to what will be considered? It's force into displacement. What is the displacement considered? It's ds. Agreed? Small amount of displacement consider. If I want to find a total work done from where to where? So initial position is S1, final position is S2. So what should I go for? Integration. Choose what is integration of dw will be equal to w upper limit minus lower limit. What is integration of f into ds? F was constant. Integration of ds will be equal to what? S. Lower limit is this, upper limit is this. Is this clear, students? क्या ये clear हुआ, students?
Yes, sir.
Students, is this clear to all of you all?
Yes, sir.
Yes, sir.
Yes.
Can I erase this, students?
One second.
स्टूडेंट्स ये ध्यान में रखना, जब भी तुम डेरिवेटिव्स और इंटीग्रेशन करते हो स्टूडेंट्स ये ध्यान में रखना। मुझे बताओ स्टूडेंट्स, व्हेन डू यू गो फॉर डिफरेंशिएशन? डिफरेंशिएशन यानी किसके लिए जाते हो तुम? व्हाट एग्जैक्टली यू ट्राई टू गो फॉर इट? व्हेन यू ट्राई टू गो for uniform graph you go for differentiation, or for non-uniform graph, students?
सर नॉन यूनिफॉर्म।
Of course, मुझे ये बताओ स्टूडेंट्स, स्लोप निकालना है तो स्लोप का दो तरीका होता है, एक तो यूनिफॉर्म और नॉन यूनिफॉर्म के लिए। ध्यान से सुनना, एक सिंपल लॉजिक है। यूनिफॉर्म के लिए सर सीधा फॉर्मूला है सर, सीधा फॉर्मूला है। पॉइंट स्लोप फॉर्म, स्लोप इंटरसेप्ट फॉर्म, y2 minus y1 upon x2 minus x1, चलो वो सीधा फॉर्मूला है। tan थीटा y by x सीधा फॉर्मूला है, वो यूनिफॉर्म ग्राफ के लिए। लेकिन अगर मैंने ग्राफ नॉन यूनिफॉर्म दिया तो उसका स्लोप कैसे निकालोगे? सर उसका स्लोप अगर मैं निकालूंगा तो एक तो मुझे सीकेंट बनाना पड़ेगा, क्योंकि नॉन यूनिफॉर्म ग्राफ है। सीकेंट लोगे तो उसके अंदर तुम्हारा स्लोप सही तरीके से नहीं आएगा, वो तुम्हारा एक पार्ट एवरेज बन जाता है। अगर उसी को मैं टेंजेंट ले लेता हूँ, दैट बिकम्स अ स्लोप, तो वो हो जाएगा इंस्टेंटेनियस पे चला गया, लिमिटिंग पे चला गया तो मेरा डिफरेंशिएशन में चला जाएगा। यानी कुछ समझ रहे हो स्टूडेंट्स? नॉन यूनिफॉर्म ग्राफ के अंदर when you try to find out slope of such non-uniform graph, you need to go for differentiation. Whereas if I give you geometrical shape structures, then if I tell you to find out area under the graph, that is more easy. Rectangle, triangle. But if I give you non-uniform graph, for that, how do you go for area under the graph? Integration. यानी इंटीग्रेशन प्रिसाइजली है क्या, डेरिवेटिव्स प्रिसाइजली है क्या कैलकुलस के अंदर, differentiation or integration precisely is concerned in physics for non-uniform graphs. Wherever graphs are non-uniform, and if I need to find out slope of those kind of graphs, or if I want to go for area under those kind of graphs, then simply I have to go for differentiation and I have to go for integration. क्या ये clear हुआ students?
Yes, sir.
Yes, sir.
Can I erase this now?
Yes, sir.
Yes, sir.
Yes, sir.
So now suppose if I say a force of 0.5 times x plus 10. Okay. Newton. Acts on a particle, students. Okay. Acts on a particle where F is in Newton, X is a displacement in meter. Students, you have to find out the work done. You have to find out the work done by the particle, students. When the particle undergoes a displacement, from x is equal to 0 meter to x is equal to 2 meter. Can you solve this question, students? Is the question clear to all of you, students? Force acting on a body is a function of displacement, and it is given as 0.5 x square plus 10x minus 5 in Newton. So force is in Newton, displacement is in x. Find out the work done in order to displace the particle from x is equal to 0 meter to x is equal to 2 meter. क्या ये clear हुआ, students? अरे हाँ या ना तो बोलो, clear है कि नहीं है?
सर
Yes,
एक
sir.
बार क्वेश्चन वापस से
इतना इतना
समझाओ।
इतना रोते हुए क्यों बोल रहे हो? ये सर, हाँ रोते हुए क्यों बोल रहे हो? क्लियर है स्टूडेंट्स?
Yes, sir. Yes, sir.
यस सर। पीयू कभी नहीं रोती है, पीयू सबको रुलाती है, खुद कभी नहीं रोती। Tejas has got the answer. Shall we solve, friends? He's got the answer is 42 June. Can we solve it, students?
Yes, sir.
Yes, sir.
Now listen carefully, students. Work done in this case, students, what is actually the formula will be equal to? Sir, work done we consider force into displacement. Is that clear? So now suppose if I say, let us say that the work done for a small displacement dW is equal to force into dx. Let us go for integration in this case. So the total work done will be equal to integration of F into dx. The lower limit is x1, upper limit is x2. How much is force is 0.5 x square, students, plus 10x minus 5 bracket close into dx हो जाएगा. तो वर्क डन विल बी इक्वल टू सर ये तो तुम्हारा सेपरेशन हो जाएगा u प्लस p इन टर्म्स ऑफ इंटीग्रेशन में भी तुम कर सकते हो. तो ये क्या होगा? सो इंटीग्रेशन ऑफ 0.5 x square into dx होगा प्लस इंटीग्रेशन ऑफ 10 into x into dx होगा माइनस इंटीग्रेशन ऑफ 5 into dx हो जाएगा. इनिशियल लिमिट क्या होगा सर? इनिशियल इज x1, फाइनल इज x2. सब जगह पे इनिशियल x1, x2, x1, x2. क्या ये क्लियर है स्टूडेंट्स? स्टूडेंट्स क्या ये क्लियर हुआ? ऑल ऑफ यू ऑल?
Yes, sir.
Yes, sir.
डन विद ऑल ऑफ यू ऑल. तो यहाँ पे तुम्हारा 0.5 कांस्टेंट बार आएगा और इज इंटीग्रेशन ऑफ x raised to n into dx. Since x raised to n plus 1 upon n plus 1, so it's 2 plus 1 upon 2 plus 1. Lower limit क्या है? 0. Upper limit क्या है? 2 plus 10 is a constant. Integration of x into dx. It's x raised to n plus 1 upon n plus 1. Lower limit is what? 0. Upper limit is 2. Minus 5 constant. Integration of dx will be equal to x. Lower limit is 0. Upper limit is 2. Solving it further, 0.5, that means 5 by 2. 5 by 10 we consider. So I can consider this is 3. So can I say this will be 5 by 30. 5 and 10. 5 twos are. Isn't it? So that will be 6. Means 5 by 10. So 2. So can I say 1 by 6 हो जाएगा students? Is this clear?
Yes, sir.
Are you getting it?
So the complete thing you solved with the brackets.
Yeah, I separated all of them. I've separated all of them. And ये क्या होगा? X cube यानी x cube 0 to 2 plus 10 by 2 कितना हो जाएगा? 5. X square is the power of 0 to 2 minus 5x 0 to 2. Solving it further, work done will be equal to 1 by 6. Upper limit minus the lower limit, so it's 2 cube minus 0 cube plus 5 into bracket. 2 square minus 0 square minus 5 into bracket. 2 minus 0. Students, क्या ये clear हुआ students?
Sir, 1/6, how it came?
Yes. So
0.5 by 3 होगा ना? 2 plus 1 is 3. So 5 by 10, 30 by 6 है.
sir,
ये 2
अच्छा, okay, sir.
सब 0.5 को 1/2 लेके तो भी हो जाएंगे।
1 by 2 भी लोगे तो भी 6 ही आएगा ना? है ना?
yeah.
आया ना?
Yes.
Okay, fine.
Yes.
Now that is equal to 1 by 6. 2 cube यानी क्या होगा? 8. Okay. Plus 5 into 4 क्या हो जाएगा? 20 हो जाएगा. Minus 5 2 जा 10. इधर से 8 by 6 plus 10 हो जाएगा. LCM is 6. 60 plus 8, 68. Can I get it in the reduced form? 2 3s are 2 3s are 2 4s are. Tejas, got it, Tejas?
Sir, I did mistake in that solving brackets.
What did you do? What did you do?
Sir, that brackets one, integration, definite integration.
हाँ. तो तूने क्या किया?
सर वो मल्टीप्लिकेशन में गड़बड़ हो गई, लाइक उधर।
Okay, fine. And PO इंटीग्रेशन इसलिए क्योंकि मैंने लिमिट्स दे दी है. स्टूडेंट्स क्या समझ में आया? ये वाला ऐसे क्वेश्चंस होता है.
Yes.
Yes, sir.
Okay, sir.
Pardon? That is why basic maths is done with you all students. Basic maths का रीजन ये है. और फिजिक्स के अंदर बहुत ही कम एप्लीकेशन होता है बेसिक मैथ्स का इनिशियली इन दैट केस यानी नॉट टू दैट एक्सटेंट दैट टफ. सिंपल मैथमेटिकल रिलेशंस आर यूज्ड. ये सिंपल मैथमेटिकल रिलेशन हम लोगों ने यूज किया. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
Sir,
हाँ बोलो.
the graph of this equation, this work done will be non-uniform, right? Like
ऑफ कोर्स नॉन यूनिफॉर्म ही होगा. नॉन यूनिफॉर्म ही होगा ना.
yes, sir.
कैन आई इरेज इट स्टूडेंट्स?
Yes, sir.
नेक्स्ट. स्टूडेंट्स एक चेन है, ध्यान से सुनना स्टूडेंट्स, एक चेन है और उस चेन को मैंने टेबल टॉप पे रखा हुआ है. The length of the chain is L and its mass is capital N. क्या ये क्लियर हुआ स्टूडेंट्स? The total length of the chain is L and mass is capital N. हाँ स्टूडेंट्स,
Yes, sir.
क्वेश्चन मेरा ये है स्टूडेंट्स, ध्यान से सुनना स्टूडेंट्स. I am trying to apply a small force. You can say I'm trying to apply a force, okay, so that the chain moves with a constant speed up over the edge of a table. So due to application of force, students, okay, the hanging mass of the chain, the answers here are students, the hanging mass of the chain is pulled slowly at a constant speed. Pulled at constant speed. Are you getting it? Surface is frictionless. There is no friction acting on the surface. There's no friction acting on the surface. Okay? Calculate the work done. Options are m into g into L, m into g into L by 2. Option C, m into g into L root D 3 by 2 mgl. M is a mass. I'll consider small m is a mass. I'll consider mass is smaller of the chain. Is smaller is the mass and L is the length. Students, क्या question clear हुआ students?
Yes, sir.
A chain of mass small m, length L is placed on a tabletop, students, and the tabletop is not offering any friction. I'm trying to hold one end of the chain and I'm pulling it horizontally in order to lift the hanging weight of the chain vertically upwards, students. Okay. The question is, students, the chain which is getting pulled, it's pulled with a constant speed. I wanted to find out work done in pulling the chain. कैसे करोगे?
So L is the length here, right?
Yes, L is the length of the entire chain. Which one should I do it for now? Ashwin? Students, hi now, hold on, please.
Sir, is the chain hanging downwards the half of the total length?
What makes you to say half of the total length?
Sir, the option B.
Huh? Since you see half of it, that's why.
Yes, sir.
चल मैंने पढ़ा दिया रे यार, मेरे से गलती हो गई. Who's this? My Albert Einstein.
Yes,
Tejas.
sir.
मैं पढ़ा देता हूँ, मेरी गलती हो गई बस. बस बढ़ा दिया मैंने और इसको छोटा कर दिया बस. खुश? Students, let me answer how to go about this. Students, let us say that this part which is onto it is x. Total length is L, तो कहने से ये कितना होगा L minus x. ये क्लियर हुआ स्टूडेंट्स?
हाँ, sir.
Yes,
Yes.
sir.
अभी ध्यान से सुनना, ये सोचो कि तुम्हारा टेबल टॉप ये है, ध्यान से सुना स्टूडेंट्स, ये सोचो कि जो पूरा चेन है, पहला पूरा चेन लंबा था स्टूडेंट्स, पूरा चेन लंबा था, तुमने यहाँ से पकड़ के रखा हुआ, फिर उसको खींच रहे हो, तो इनिशियली तुम्हें चेन को x इज इक्वल टू 0 और खींचते 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 लंबा तक लेके आना है, तो x इज इक्वल टू l, पूरा चेन ऊपर लेके आना है, वर्क डन इन ऑर्डर टू पुल द चेन एंड प्लेस इट ऑन द हॉरिजॉन्टल, तो कहने से आई एम गेटिंग टू लिमिट्स, 0 टू l तक जाना है स्टूडेंट्स, हाँ या ना?
Yes, sir.
सोचो कि पहला चेन पूरा ऐसा और फिर तुम उसको धीरे धीरे खींच के हॉरिजॉन्टली लेके जा रहे हो, तो कहने से यू हैव टू गो फॉर द एंटायर chain should now come on the surface we consider. So my limits will be what? Initial limit is 0, final limit is capital L. क्या limits clear हुआ स्टूडेंट? सबसे पहले बताओ।
Sir,
हाँ बोलो।
x equals to 0. Can you repeat that again?
If in case if I'm holding the, see मैंने डायग्राम ऐसा बनाया, अगर सोचो कि ये एंड यहाँ पे है
Okay.
and then I'm pulling it, so entire weight of the chain I'm pulling it. Am
Yes.
I agreed? So what exactly my limits I'll consider will be equal to what? 0 to L.
Oh, yes. Like starting when there is nothing, and afterwards you're just pulling it entirely upwards.
And I want the entire, यानी फाइनल जब इनिशियल ये होगा, ये फाइनल, जब भी मैं फाइनली पोजीशन देखूंगा तो मेरा पूरा चेन ऊपर आ गया।
Yes, understood. Understood.
That's what we consider. That's the limits we take it. अभी ध्यान से सुनना शुरू। Now let us go with respect, यानी सबसे पहले तुम्हें लिमिट्स को डिसाइड करना जरूरी है कि यहाँ पे लिमिट्स क्या होंगे। दूसरी बात ना, लेट अस गो फॉर मास। अभी ध्यान से सुनना, मैंने कैपिटल एल के लिए मास एन लिया, तो कहने से स्मॉल एन अपॉन कैपिटल एल इज मास ऑफ द टोटल लेंथ। Suppose if I now say this is x and this is L minus x, let us go for L minus x, which is the hanging part of it. Students, let us find out the work done for the hanging part. Doesn't matter. And that work is done against gravity, na students? हम लोग pull कर रहे हैं, तो it's work done against gravity. So students, अगर मैंने पूछा, can you tell me what is the mass for L minus x? तो क्या करोगे? सर जो m dash होगा वो L minus x into m upon L हो जाएगा। क्या ये क्लियर हुआ स्टूडेंट्स?
नहीं समझा।
हेलो, पियो 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 पियो, ये 10 सेंटीमीटर है, पियो कितना है?
Yes, sir. 10 centimeters.
इसका मास 10 ग्राम्स अज्यूम, हाँ
हाँ, okay.
10 grams upon 10 centimeter, agreed? So what is the mass of 1 centimeter? Cross multiply.
Okay, yes. हाँ, thank you, sir. Okay.
यानी मैंने L minus x लिया। Students, for L minus x, what is the mass? L minus x mg. Now, if I say what is the force required, the answer is what is the force required to lift this? So the force required will be equal to mass into acceleration to gravity. So then I say the force required will be equal to what? L minus x small m upon L into g. क्या ये clear हुआ?
Yes.
Students, क्या ये clear हुआ सबको? How much is the force required in order to pull the hanging part of the string or the hanging part of the chain? The force required is equal to the weight of that particular string. And what is the weight of that particular string or the weight of that particular chain? L minus x mg upon L. क्या ये clear हुआ? इतना तो force मुझे लगाना ही है, हाँ या ना?
Yes, sir.
अभी
Yes,
ये
sir.
सोचो, अभी ये सोचो कि मैंने पहले उसको डिस्प्लेसमेंट, मैंने इसको डिस्प्लेस किया, एंड लेट अस से माय डिस्प्लेसमेंट इज वेरी स्मॉल dx. सपोज मैंने dx का डिस्प्लेसमेंट लिया, लेट अस से द वर्क डन, लेट अस फाइंड आउट द वर्क डन फॉर दिस फोर्स एंड द डिस्प्लेसमेंट इज dx. But we need to find out the work done for total displacement from where to where? 0 to L. So this is 0 to W. This is small x is equal to 0. Small x is equal to L. Integration of dw will be W. Integration of f will be what? L minus x mg upon L. Initial is 0, final is L. Now students, can you solve this simple integration? तो क्या करोगे तुम? सर इसको हम सॉल्व करेंगे, ये मल्टीप्लाई करो तो सर ये L इंटू एम जी अपॉन L होगा माइनस x इंटू एम जी एग्रीड अपॉन L हो जाएगा 0 to L 0 to L। क्या ये क्लियर हुआ सबको?
Yes, sir.
Yes, sir.
all of your students, is that clear, students?
Yes, sir.
Yes, sir.
Okay. Now, if in case if I happen to consider in this case, so what do I take it in this case? So it's L minus X. Very sorry, into dx. I'm very sorry. My dx is existing over here. I must start with dx. ये dx होगा. I'll rewrite it below. Please. F into dx. ये F आया. mg into dx. Now I'll rewrite it. Students आंसर सुनना. अभी यहाँ पे constant terms क्या होंगे? मुझे बताओ students. मुझे सर mgl constant आ जाएगा. तो can I remove this outside? Mass, gravitational acceleration, actual नहीं तो पूरा constant है. Constant terms कभी integrate नहीं होते students. Agreed?
Yes, sir.
इंटीग्रेशन ऑफ क्या होगा? L minus x into dx. ये क्लियर हुआ स्टूडेंट सबको?
Yes, sir.
Yes, sir.
ओके, नाउ कैन आई स्प्लिट अप दिस? हाँ सर, इसको तुम कैसे लिखोगे? mg by L इंटीग्रेशन ऑफ L into dx 0 to L minus इंटीग्रेशन ऑफ x into dx 0 to L. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
नाउ व्हेन आई सॉल्व इट, mg by L integration, can I say L is constant? What is integration of dx? X
L.
X.
minus. So what is integration of x into dx? What is integration of x into dx?
Square by 2.
Now solving it further, students. ध्यान से देखना अभी. Equal to mg by L ब्रैकेट में ये क्या है? Can I substitute x as L upper limit minus lower limit L minus 0, तो L ही बचेगा. L into L क्या हो जाएगा? L square minus L square by 2. What is 1 minus half? What is 1 minus half? Half. What's my answer? Which is the option?
So why you substituted x में L?
My dear, ये सब इंटीग्रेशन है. ये किया है ना तुम लोगों ने? ये इंटीग्रेशन है my dear.
Yes.
And see, somebody I know
Sorry,
who, that Einstein guy, who he answered just like that. है ना? mgl by 2 and he got it correct.
Yes, sir.
लेकिन स्टूडेंट्स कुछ समझ में आ रहा है मैंने क्या किया?
Yes, sir.
आंसर
Yes,
के
sir.
लिए मैंने क्या किया मालूम है? मैंने एक छोटा सा लेंथ उसको सोचा सस्पेंड किया है. उसका फिर मैंने मास निकाला. तो कौन सा कितना फोर्स चाहिए उसको खींचने के लिए? तो ये फोर्स चाहिए. तो अगर सपोज मैंने ऊपर खींचा उसको खींचने के लिए, लेट अस से द डिस्प्लेसमेंट इज दी, तो मेरा फोर्स, मेरा वर्क डन इज आल्सो वेरी स्मॉल f into dx. तो ये फोर्स मैंने डाल दिया, into dx ले लिया. फिर यहाँ पर मैंने सॉल्व करने के बाद में mg by L मैंने कांस्टेंट निकाल दिया. फिर सिंपली u minus v मेथड लेके सेपरेट कर दिया. फॉर्मूला इंटीग्रेशन ऑफ dx is x, इंटीग्रेशन ऑफ x into dx is x square by 2. फिर अपर लिमिट को सॉल्व करो, लोअर लिमिट को, बिकॉज़ दीस आर डिफरेंट इंटीग्रल्स. कांस्टेंट ऑफ इंटीग्रेशन आएगा नहीं. फाइनल आंसर mgl by 2. और अभी इसको स्टूडेंट कैसे याद करते मालूम है? इसको स्टूडेंट कैसे याद करते हैं? अभी यही सोचो, ध्यान से सोचना. सपोज अगर ये पूरा वायर लंबा नीचे होता स्टूडेंट्स, अभी ये सोचो कि ये पूरा वायर है. ओके, ये पूरा वायर और मैं खींच रहा हूँ. मुझे खींचना है, शुरुआत यहाँ से करनी है. Can I say the entire length of the wire is suspended vertically? क्या ये क्लियर है?
Yes, sir.
मुझे बताओ स्टूडेंट्स, where is the weight of this particular wire is directed? तो क्या बोलोगे? सेंटर ऑफ ग्रेविटी या सेंटर ऑफ मास, है ना? आया ना?
Yes, sir.
Yes.
Yes, sir.
तुम्हारा फोर्स जो ऊपर की तरफ एक्ट हो रहा है, उसको काउंटर बैलेंस कौन सा फोर्स एक्ट कर रहा है? वेट. लेकिन ये वेट कहाँ पे एक्ट हो रहा है? इज इट एक्टिंग अलोंग द टोटल लेंथ और हाफ द लेंथ ऑफ द वायर? Students?
Half the length.
Half.
That is why the force applied will be equal to half that mgl by 2. ये directly students remember it. कोई भी बॉडी, तुम लोग ने फ्री बॉडी डायग्राम्स किया होगा ना स्टूडेंट्स. एक सिंपल एग्जांपल है यार. अगर तुमने कोई रोप को लिया है, अगर तुमने रोप दिया है, वर्क पर एनर्जी में तुमने किया होगा. अगर रोप को तुमने सस्पेंड किया स्टूडेंट्स, एक रोप है, ओके, उसको सस्पेंड किया है. मैंने पूछा वेयर आर द फोर्सेस एक्टिंग ऑन रोप, तुम बोले सर रोप का खुद का भी तो वेट होगा. तो उसका वेट सेंटर ऑफ मास से नीचे की तरफ जाता है और ऊपर की तरफ टेंशन चला गया, लेकिन ये जो फोर्स एक्ट हो रहा है, इज इट एक्टिंग ऑन द एंटायर लेंथ ऑफ द रोप और हाफ द लेंथ ऑफ द रोप?
Half the length.
है ना, दैट्स व्हाट इट इज. सो हाफ द वेट. क्या ये क्लियर होगा? इज दिस क्लियर? हाफ द
Yes.
लेंथ.
Yes, sir.
Yes, sir.
कैन आई इरेज दिस स्टूडेंट्स?
Yes, sir.
Yes, sir.
No, sir, just a minute.
हे भगवान, प्रियो तो डरा देती है. So out of this, it's only the work part which was a tough one. Now its energy and power is very easy.
Yes, sir, done. Thank you.
क्या erase कर दूं मैं?
Yes, sir.
तो अगर तुम बोर्ड्स के हिसाब से कर रहे हो, आई डोंट नो अबाउट इट, अगर तुम्हारे स्कूल्स में इंटीग्रेशन किया होगा तो ऐसे क्वेश्चंस डालेंगे, अगर नहीं किया होगा तो ऐसा कोई क्वेश्चंस डालेगा भी नहीं. डोंट टेक
सर स्कूल में ऐसे नहीं पढ़ा रहे.
ऐसे नहीं पढ़ा रहे तो क्या पढ़ा रहे?
सर थोड़ा फास्ट जा रहे.
ओके. लेकिन समझ में आ रहा है जो कुछ भी है?
Yes, sir. Yes, sir.
Okay, अभी ध्यान से सुनो स्टूडेंट्स. Now we speak about energy. Students, energy के अंदर हमारा we consider what energy is. We consider what? Okay. Energy is defined as a capacity of a body to perform work. Students, it's a capacity of a body to perform work. Students. There are several forms of energy in the universe. Heat, light, sound, chemical, mechanical, electrical, different forms of energy. Students, you getting it? हम हमारा जो scope of syllabus के हिसाब से जाएगा students, वो है mechanical energy. Since mechanical energy is the energy which is used to perform mechanical work. Okay, the energy which is used to perform mechanical work is called mechanical energy. This mechanical energy is actually of two types. One of them is called kinetic, the other one is called potential. Kinetic, students, is always based on the motion of a body. Any object when set into motion, it will have kinetic energy. Any kinetic energy be several types के students. अगर तुम kinetic energy भी देखोगे, so it can be students translational, it's vibrational, also called as, I can consider oscillatory, and rotational. तुम तीन टाइप ऑफ काइनेटिक, लेकिन तुम्हारे स्कोप के अंदर तुम ये पकड़ सकते हो ट्रांसलेशनल. Potential energy, students, are of several types, लेकिन तुम्हारे लिए I can go for elastic potential energy and gravitational. Students, ये जो elastic potential energy की तुम U और E लिख सकते हो, gravitational potential energy को U और G लिख सकते हो, कोई प्रॉब्लम नहीं. Common U आता है. Symbol U stands for potential energy. Symbol K stands for kinetic. Kinetic energy translational, kinetic energy vibrational, kinetic energy rotational. Kinetic energy translational का फॉर्मूला क्या होगा सर? हाफ एम वी स्क्वायर. ये ध्यान रखना, ये हाफ एम वी स्क्वायर होगा. Kinetic energy vibrational oscillation में क्या होगा सर? हाफ एम ओमेगा स्क्वायर इंटू ब्रैकेट ए स्क्वायर माइनस एक्स स्क्वायर. ये तुम कभी पढ़ोगे स्टूडेंट्स? मालूम है? नेक्स्ट ईयर पढ़ोगे. कहाँ पे? चैप्टर कॉल SHM, जो अभी 12th स्टैंडर्ड में चल रहा है. सिंपल हार्मोनिक मोशन अभी शुरू है. ठीक है. सो ये है तुम्हारा SHM स्टूडेंट्स. हाफ एम ओमेगा स्क्वायर इन ब्रैकेट ए स्क्वायर माइनस एक्स स्क्वायर. काइनेटिक एनर्जी रोटेशनल, सो इट्स हाफ आई ओमेगा स्क्वायर. जब तुम रोटेशनल डायनामिक्स करोगे तो वहां पे तुम्हारा ये आएगा. ये तीन टाइप है तुम्हारा. ये पार्ट तुम्हें पकड़ना है. फ्रेंड्स, इलास्टिक पोटेंशियल एनर्जी के बारे में करोगे तो ये होगा हाफ के एक्स स्क्वायर होगा स्टूडेंट्स. ये के का मतलब स्प्रिंग कांस्टेंट. शायद तुम लोगों ने लॉज ऑफ मोशन में स्प्रिंग फोर्स के बारे में पढ़ा होगा.
Yes, sir.
इलास्टिक कांस्टेंट. ओके. F is equal to minus kx. तो ये वाला k है. ये k को हम क्या बोलते हैं? इलास्टिक कांस्टेंट, फोर्स कांस्टेंट, स्प्रिंग कांस्टेंट. तीन अलग अलग नाम है लेकिन है सेम. डिपेंड्स ऑन द मटेरियल. तो ये इलास्टिक पोटेंशियल. ग्रेविटेशनल पोटेंशियल एनर्जी इज बेस्ड ऑन द पोजीशन स्टूडेंट्स. Gravitational potential is based on the position. Elastic potential is based on the shape or configuration. यानी अगर मैं इलास्टिक पोटेंशियल की बात करूँ तो क्या ना इसे कंप्रेस स्प्रिंग इलास्टिक पोटेंशियल एनर्जी. A stretched spring, elastic potential energy. A stretched bow, elastic potential energy. A stretched rubber band, elastic potential energy. But if I say water stored in the reservoir of a dam, gravitational potential energy. A raised hammer, gravitational potential energy. Yes, some gravitational potential energy, and the formula is what? mgh. क्या ये clear हुआ, students?
Yes, sir.
Yes, sir.
Now when you speak about it, students, you have different forms of energy. Students, अगर तुम energy का unit भी देखोगे ना, तो अलग-अलग forms में energy you can measure. Students, ये भी ध्यान रखना, students. जब भी हम mechanical energy के बारे में बात करेंगे, students, mechanical energy. So students, mechanical energy can be considered either in joule or in erg. I can consider. Okay. Energy is always measured in joule and erg. Students, ये ध्यान में रखना. Work is also measured in joule and erg. Energy also is measured in joule and erg. Students, ये ध्यान में रखना. Then you have one form of energy also, students. अगर मैं suppose heat energy को, ध्यान से सुना students. Heat energy का SI unit क्या? तो तुम बोलोगे joule. लेकिन क्या heat can be measured in joule? हाँ students?
No, sir.
Sir, Kelvin.
तो measure किस में होगा? किलो कैलोरी में. ये ध्यान रखना. यानी measurement of heat is never in joule. SI is joule, measured in kilo calorie and calorie. 1 kilocalorie, students, is equal to how many calorie? 1000 calorie. 1 calorie is equal to how many joules? So 4.186 joules. 1 kilocalorie is equal to how many joules? 4186. क्या ये क्लियर हुआ स्टूडेंट्स? कन्वर्जन ये सबको तुमने लोअर स्टैंडर्ड में पढ़ा है, अभी भी रिसेंटली 10th में पढ़ा हुआ स्टूडेंट्स, हीट एंड कैलोरीमेट्री में. तो हीट एनर्जी का एसआई जूल है, लेकिन कभी भी हम जूल में मेजर नहीं करते, हम किलो कैलोरी और कैलोरी में मेजर करते हैं स्टूडेंट्स, है ना. दूसरा और एक है एनर्जी ऑफ इलेक्ट्रॉन, दैट इज कॉल्ड एज एटॉमिक एनर्जी. शायद तुम लोगों ने पढ़ा होगा ड्यूरिंग ट्रांजिशन ऑफ एन इलेक्ट्रॉन. हाँ स्टूडेंट्स, जब भी इलेक्ट्रॉन ट्रांजिट करता है, ध्यान से सुनना, फ्रॉम हायर एनर्जी लेवल टू लोअर एनर्जी लेवल, तुम लोग ने केमिस्ट्री में भी पढ़ा होगा. जब ये इलेक्ट्रॉन जंप मारेगा टू फ्रॉम हायर एनर्जी लेवल टू लोअर एनर्जी लेवल, कहने से इट स्टार्ट्स रेडिएटिंग एनर्जी. है ना स्टूडेंट्स?
Yes, sir.
Then what?
Yes, sir.
पढ़ा है कि नहीं पढ़ा है?
Yes, sir.
So that is in EV.
सब
EV का
photons भी.
electron volt. Of course, energy is in form of small packets. Photons, energy of photon. EV, 1 electron volt. Since 1 electron volt is equal to how much? 1.6 into 10 raised to minus 19 joule. ये ध्यान रख. अगर वही मैंने पूछा न्यूक्लियर एनर्जी, स्टूडेंट्स न्यूक्लियर एनर्जी अगर मैं बोलूं, so that nuclear energy is always measured in MeV, mega electron volt. ये ध्यान रखना स्टूडेंट्स. एटॉमिक एनर्जी इज ऑलवेज इन EV, न्यूक्लियर एनर्जी इज मेगा. मेगा का क्या करना है? into 10 raised to plus 6 आएगा स्टूडेंट्स. तो इसका आंसर होगा 1.6 into 10 raised to minus 19 plus 6 to minus 13 जूल. और एक फॉर्म ऑफ एनर्जी तुम लोग ने पढ़ा है स्टूडेंट्स, इलेक्ट्रिकल एनर्जी. अगर सपोज मैंने पूछा व्हाट इज द इलेक्ट्रिकल एनर्जी कंज्यूम्ड इन हाउस होल्ड इलेक्ट्रिसिटी, स्टूडेंट्स हाउस होल्ड इलेक्ट्रिसिटी में इलेक्ट्रिकल एनर्जी कैसे करना है? तुम क्या बोलोगे सर? किलोवाट आवर, किलो वोल्ट एम्पियर आवर. ये पढ़ा कि नहीं पढ़ा स्टूडेंट्स 10th में?
Yes, sir.
किलो वोल्ट आवर और किलो वोल्ट एम्पियर आवर, पावर इनटू टाइम, and power is V into I, VIT. Since 1 kilowatt hour corresponds to how many joules? 3.6 into 10 raised to 6 joules. तो ये सारे conversion of units ध्यान में रखना स्टूडेंट्स while going for energy part of it. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
Yes.
Can I read this please?
Yes,
Can I
sir.
read this? Erase करूँ मैं इसको?
Sir, 1 minute. Sir, 1 minute.
The students' elastic potential energy is based on to shape or configuration. Gravitational potential energy is based on to position, that is mgh. Translation kinetic energy is half mv square. There are other also oscillatory, or that is vibrational and rotational. Whereas mechanical energy is joule or erg, heat energy is measured in kilocalorie, atomic energy is measured in EV, nuclear energy is measured in MeV, electrical energy is measured in kilowatt hour. So can you give me the relation between momentum and kinetic energy? ये बहुत important relation है, इसके related शायद question पूछेंगे. I wanted to give me relation between momentum and kinetic energy. Anybody give me linear momentum and linear kinetic energy? That is translational kinetic energy and linear momentum. कोई relation बता सकते हैं students?
Proportional.
बोलो.
Yes, sir, directly proportional.
Linear momentum equal to under root 2mk. Students ये बहुत important है and I'm 200% sure अगर तुम्हारी एग्जाम्स होगी स्कूल्स में इसके रिलेटेड एक क्वेश्चन तो आएगा, या तो डिराइव करेगा या तो कोई प्रॉब्लम पूछ लेगा. स्टूडेंट्स तुम्हें क्या देंगे मालूम है? तुम्हें काइनेटिक एनर्जी देंगे और मास देंगे और लीनियर मोमेंटम पूछेंगे, या मोमेंटम और मास देंगे टिल फाइंड आउट काइनेटिक एनर्जी. स्टूडेंट्स इट्स वेरी इजी. लीनियर मोमेंटम इज अंडर 2mk. ये एक फार्मूला है.
Sir, this is done in atomic structure.
Pardon?
Sir, this formula is done in atomic structure.
Yes. काइनेटिक एनर्जी का फॉर्मूला क्या स्टूडेंट्स? काइनेटिक एनर्जी का फॉर्मूला हाफ एम वी स्क्वायर है, सबको पता है. सर मल्टीप्लाई न्यूमरेटर बाय मास, डिनोमिनेटर बाय मास. आ गया ना? स्टूडेंट्स व्हाट इज m into v? लीनियर मोमेंटम. So can I say it's p square by 2m? What is p square? 2mk. If p square is equal to 2mk, what is p? 100 2mk. यानी linear momentum is directly proportional to square root of translation kinetic energy. Square root of translation kinetic energy keeping mass of the body constant. यहाँ पे velocity कहीं पे भी नहीं आ रहा स्टूडेंट्स, ये ध्यान में रखना. जब भी तुम प्रॉब्लम सॉल्व करो तो v को नहीं कंसीडर करते हैं. And if I keep m constant, then p is proportional to root of k. क्या ये क्लियर हुआ? Can I erase this, students?
Yes, sir.
Okay. Students, the next is your work energy theorem. Students, what exactly work energy theorem speaks about? Students, work energy theorem speaks about work done by a force. Students, अब ध्यान से सुनना. Work done by force. It is simply change in kinetic energy. ध्यान से सुनना फ्रेंड्स. वर्क डन बाय फोर्स इज सिंपली इक्वल टू चेंज इन काइनेटिक एनर्जी. यानी अगर मैं अप्लाइड फोर्स बोलूंगा तो दैट विल बी इंक्रीज इन काइनेटिक एनर्जी बिकॉज़ आई एम अप्लाइंग फोर्स, सो द फाइनल विल बी ग्रेटर देन इनिशियल, तो ऑलवेज इंक्रीज इन काइनेटिक एनर्जी. अगर सपोज मैंने वर्क एनर्जी थ्योरम, सम पीपल आल्सो स्टेट इन दिस मैनर स्टूडेंट्स, वर्क डन बाय अप्लाइड फोर्स इज इक्वल टू इंक्रीज इन काइनेटिक एनर्जी. स्टूडेंट्स सही है ना? फोर्स अप्लाई करते जा रहे हो ना तुम, तो फाइनल वेलोसिटी विल बी ग्रेटर देन इनिशियल, so there will be increase in kinetic energy. लेकिन अगर सिंपली मैं बोलूं work done by force, so it has to be change in kinetic energy. Change का मतलब क्या हुआ? Kinetic energy final minus kinetic energy initial. ये ध्यान में रखना. Kinetic energy final का फॉर्मूला क्या होगा? half m v square minus half m v square, and that's work done. Suppose if I say that work done is due to applied force and displacement, and if the force and displacement are considered, so can I say it's Fs cos theta? Yes. So what's the formula for work energy theorem? Fs cos theta is equal to half into m into bracket v square minus u square. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Yes, sir.
यानी अगर सपोज तुम्हारा फाइनल वेलोसिटी इज ग्रेटर देन इनिशियल वेलोसिटी, then in that case what exactly? The work done by the applied force is increasing the kinetic energy. अगर मैंने पूछा what is the work done by the force of friction, तो फ्रिक्शनल फोर्स होगा, तो विल बी नेगेटिव इन दैट केस. तो व्हाट विल बी, माय v विल बी लेस देन u. क्या ये क्लियर हुआ? Are you getting it? If v is greater than u, then the motion is accelerated. Are you getting it? If v is less than u, the motion is decelerated.
Deaccelerated.
Yes, deacceleration. Are you getting it, students? This is what we consider as work energy theorem. Is this clear to all of you all?
Yes, sir.
Now suppose if I happen to give you a spring, students, ध्यान से देखना भाई students, मुझे सिर्फ एक mathematical relation दो. ये एक spring है students, ये spring initially rest पे है, okay? इस spring को मैंने compress किया, okay? I've compressed the spring, okay, by x, and a small ball of mass m is placed onto it. Since what happens when the spring releases? I want to find out the maximum height the ball can reach. A small ball, the answer is a ball of mass small m is resting on a compressed spring. It is compressed at x. When released, what is the maximum height the ball can cover? Can you give a mathematical relation for this?
So we can do it like the elastical potential energy of the spring. That would be the kinetic energy at initial point, and then when kinetic energy would be 0, it would be equal to gravitational potential energy. That would be mgh.
Can I neglect kinetic? Can I go for directly from here till potential only?
Yes, sir. Definitely.
Law of conservation of energy. What is law of conservation of energy? Energy can neither be created nor destroyed. It can be converted from one form to another. The total amount of energy remains constant. So, ये कौन सा होगा? Elastic potential energy is getting converted to which energy? Sir, it is converted to gravitational potential energy. What is elastic potential energy? Half kx squared. What is gravitational potential energy? mgh. Sir, आपको h चाहिए. So, can I say my formula for h will be equal to what? My h will be equal to kx square upon 2mg. Is this clear?
Yes, sir.
यही
Yes, sir.
चीज मैं ऐसे दिखा दूं. मैं ऐसे दिखा दूं. ये एक रिजिड सपोर्ट है और एक स्प्रिंग है और ये ट्रॉली है स्टूडेंट्स, और इस ट्रॉली को मैं कंप्रेस करता हूँ, ओके, एक्स. ट्रॉली को मैंने कंप्रेस, और ट्रॉली अभी यहाँ पे है. अब फिर मैं इसको रिलीज करता हूँ. मुझे बताओ स्टूडेंट्स, व्हाट इज द वेलोसिटी विद व्हिच इट्स गोइंग टू मूव? तो यहाँ पे तुम्हारा लॉ ऑफ कंजर्वेशन ऑफ एनर्जी क्या होगा? हाफ के एक्स स्क्वायर कैन इज इक्वल टू हाफ एम वी स्क्वायर.
Yes, sir.
Law of conservation of energy. Elastic potential energy is getting converted to kinetic energy. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
So do take care when you're solving questions based on this. Is that clear? As height above the Earth's surface increases, students, as height above the Earth's surface increases, potential energy goes on increasing, students. The gravitational potential energy we consider as height increases, we consider in that case, okay? So we consider the U with respect to H, we consider it's mgh. The last part we consider is power, students. How is power defined as? Can you tell me definition of power, students? That's an easy part, students. So can you define power? Power is defined as what, students?
The capacity to do something.
Yes, power is defined as the rate at which work is performed. Students, power is defined as the rate at which work is performed. खत्म हो गया. यानी power, students, is equal to work done per unit time. ध्यान से देखना, अभी कितने सारे formulas में दे रहा हूँ students. बस ये इतने ही formulas याद रखने power के. That's end of power. Power is equal to work upon time. Work को कैसे करोगे students? सर ये Fs होगा upon time, क्योंकि work is dot product. What is displacement upon time, students? What is displacement upon time? Velocity. So can I say power is also a dot product of force and velocity?
Yes, sir.
अगर किसी ने वेक्टर्स में और एक एग्जांपल पूछा, वर्क इज इक्वल टू एफ डॉट एस, ये एक एग्जांपल है डॉट प्रोडक्ट का, व्हिच इज द अदर एग्जांपल ऑफ डॉट प्रोडक्ट? पावर इज फोर्स इनटू वेलोसिटी. यानी अगर इसको मैं कंपोनेंट पे लिखूं तो कहने से एफ वी कॉस थीटा. क्या ये क्लियर हुआ स्टूडेंट्स?
Yes, sir.
Now when I speak about work done, suppose अगर कोई body को students कोई body को अगर तुमने यहाँ से लेते हुए shift कर दिया at a certain height. For example, students ये तुम्हारा building है और यहाँ पे water tank है. Please pay attention, ये water tank है. और तुमने इलेक्ट्रिक मोटर से पानी को ऊपर चढ़ा दिया. I getting it? So can I say there is some power consumed by the motor and it has been stored at a certain height? What energy is getting stored over here? तो तुम क्या बोलोगे? Potential energy. So can I say power generated by the motor? The answer सुनना is a work done by motor per unit time. What is work done by motor? What is the work done? It's a useful work done. Over here हम useful work done लेते हैं. Useful work done by the motor is equal to what? The work done to lift the water at a certain height. Means can I say work done is equal to gravitational potential energy per unit time? क्या ये clear हुआ students?
Yes.
तभी जाके students power को हम we also write down as mgh upon T. समझ में आ रहा है? So power is equal to potential energy time or mgh upon T. Is that clear?
Yes, sir.
The last part, students, the last part. Suppose if I give you two positions. ये है position A और ये position B है. Students ध्यान से सुनना. अभी suppose PU को हम staircase के through भेजते हैं. Okay? 10वें माले पे जा रही है through staircases. Okay? Second case में 10वें माले पे जा रही है through inclined plane. तीसरे केस में spiral winding से वो 10वें माले पे जा रही है. और चौथे केस में elevator से 10th floor पे जा रही है. मुझे बताओ students, what is the work done in each case? Work done in each case. Is it
Yes.
same or is it different?
Same, sir. Same.
Same.
Students, work done by a person to move from point A to point Y because the displacement is same. Displacement is equal to height. भले तुम 10th फ्लोर पर जा रहे हो स्टूडेंट्स, भले तुम स्टेयरकेस से गए, तुमने एक इंक्लाइन प्लेन रख दिया, बड़ा सा इंक्लाइन प्लेन, उसको लेते हुए जा रहे हो या स्पाइरल वाइंडिंग से या लिफ्ट से जा रहे हो, चारों केस में पीयू का वेट चेंज होगा क्या? 10th फ्लोर में है तो पीयू का वेट क्या है? m into g. अगर पहले केस में तुमने वर्क डन का फॉर्मूला लगाया तो वर्क डन इज इक्वल टू व्हाट? mgh अगेंस्ट ग्रेविटी. सेकंड केस में भी क्या होगा? mgh. थर्ड केस में भी क्या होगा? mgh. फोर्थ केस में भी mgh. स्टूडेंट्स, वर्क डन इज इंडिपेंडेंट ऑफ द पाथ. अगर सपोज तुम पॉइंट ए से पॉइंट बी पे जा रहे हो तो कोई बंदा सीधा जाके, कोई बंदा ऐसे घूमते हुए जाएगा, कोई बंदा ऐसे घूमते हुए फिर इधर जाएगा. Students, work done is independent of the path. It just depends on its initial position and final position. तो सारे केस में work done is the same, but maybe time taken may not be same. है ना students? Time
Yes.
taken सबसे
Yes.
कम टाइम कहाँ पे होगा? सबसे कम टाइम कहाँ पे होगा?
Sir,
Elevator में.
live.
है ना? तो can I say power in the fourth case will be minimum? Are you getting it?
Yes, sir.
So,
And power will be maximum in what case? Depending तुम्हारा staircase कितना vertically steep और height कितना दिया है, या inclined plane का theta कितना दिया है vertical से horizontal, that depends on to that. So power is defined, students, as rate at which work is performed. Is this clear, students?
Yes, sir.
yes, sir.
That's the end of your work energy part, students. Okay. Shall we wind up now?
Okay, sir.
Okay. Shall wish you all the best.
Thank you.
Thank you, sir.
One is your. Okay,
Have a
bye.
good evening, sir. Thank